Welcome to Jack's next screencast. For this time, I'm going to look at a kata, which is a little training, a little sort of practice problem for the language Haskell. So we're just going to try and solve a tiny little function or implement a tiny little function, which takes a list of numbers and returns the representation as you would expect a phone number, at least an American phone number here on the right. So you have this 1, 2, 3, 4, 5, 6 list, and it converts it into a string that you see here. Conveniently, they give you the setup code here, the definition of the function. You just have to implement it, and they also give you some sample tests. And they're using the HSpec framework here from Haskell. And if you use a stack to set up your project, it's actually very easy to copy and paste these sample tests into a local environment, so you can really get humming on your debugging, so in your implementation. So you can simply just copy and paste the tests into a specific file. And if you enable HSpec auto discover, HSpec discover, which you just copy and paste this macro into the spec.hs file, then your stack test runner will automatically discover this isolated file here, which is testing the implementation of create phone number. So how do we get started? So to see if everything's working, you can run stack test file watch, and it's going to rebuild every single time you change the code, and you can see how things are progressing. So here we've got the build going on, and at the same time we'll take a look at how we can get started with implementation of create phone number. You can see that okay, so we have to get started somehow, so we can actually use plugin from the standard VS Code plugin, some functionality which uses a Wingman to automatically try and implement your function just based on the type definition of the function. And it's usually going to be garbage because it doesn't know anything about what task you're trying to solve. And here we can see that this implementation is basically just going to return an empty string every time. It unfolds the list of integers, ignoring the head until it gets to an empty list, and it returns an empty string. And so we expected to get the number 0, 0, 0, blah, blah, blah for our string, but we have an empty string. So we can actually get started with trying to implement this number. So let's see the different ways that we could possibly implement this. So what do we essentially have to do? We have to split our list into chunks of 3, a 3, and a 4. And then combine it all into a string. So let's see how we can go about doing that. So one way I like to do this is to work backwards. So you start with the solution, and then try and define the pieces that satisfy the solution working backwards. So what do we need? We need to concatenate a bunch of different strings. So we have the open parenthesis, we have the first 3 numbers, we have an end parenthesis, a space, and then we have the middle 3 numbers, then we have a dash, and then we have the last 3 numbers, last 4 numbers. Okay, now this will work once we define what these 3 things are. So just to start getting some feedback, we can do first 3, middle 3, last 4, and we can define it as A, B, C, and we can actually get our code to compile now. You can see that it has no dependency on numbers. That's why we have this error. That's because we have a garbage definition of first 3, middle 3, last 4. But we can see how much progress we're making towards the solution. And we wait for it to finish compiling. And we now see that, okay, it's doing roughly what we wanted to do, but the definition of first 3, middle 3, last 4 is wrong. Sometimes I like to have a faster feedback loop than what you see compiling the whole stack project. So I like to do something like this when I'm debugging. Let's go replicate. So how many digits are there? There's 10, and it's just a 0. So there's our 10 numbers, and we can print what our solution looks like, and we see it's still garbage, and we see it instantly, which is a great debugging loop. So let's kill this so we're not annoyed by what it's doing while we debug. And we can just use this simpler version at first to make sure things are looking good. All right, so let's start by saying that the last 4 is dropping 3 from the back end. Okay, and then the back end is dropping, actually, we can do it the stupid way first, and then we'll do it the slightly smarter way. So let's drop 3 from numbers to get the back end, and the front end is going to be take 3 from numbers. I think we've almost got our solution where the last 4 is dropping 3 from the back end. The middle 3 is taking 3 from the back end, and the first 3 is simply equal to the front end, the first 3 numbers. All right. Now we're getting closer to our solution, but we have a type problem. And I think it's just taking a while for this to build. Oh no, it's finding, here, we're missing an equal sign. There. So we have a type problem where we're expecting a string in this spot here, but we're actually receiving a bunch of integers. So we actually want to take all of these chunks, last 4, middle 3, first 3, and turn them into strings by concatenating them. So concatenating the digits. So what are we going to do? We're going to define the string method, which is going to take a bunch of numbers, and it's going to concat map show numbers. Super cool. So concat map is basically a flat map. It first performs a map operation on each item in numbers, and running show actually returns a list of characters. So concat map is going to concatenate the list of characters into a single list of characters, which represents a string in Haskell. And because we're being fancy, we just need to do concat map show and not, they call this point-free representation in Haskell, where you don't specify the argument because it's redundant in the definition. All right, so we have our toString definition. Now let's go ahead and convert all 3 of these into the final representation that we want. So we can go first 3, middle 3, last 4. So let's make it a list first, because that's the simplest way of doing it, which is going to be map to string first 3, middle 3, last 4. And this works. A little bit upset because it's not smart enough to detect that this is a list that's length 3 and you're mapping it to a list of length 3 on the other side using map. But it's saying that if you're performing a map decomposition, you don't know what the length of the list is necessarily. So you need to do better pattern match or a more exhaustive pattern matching. We know, since we're only passing a list of length 3, that we're only going to get out a length 3, but this warning does not recognize that. So I think there might be a way to do this using the lens package. Each to string, and then you can pass this in as a let's see how that goes. Wow, I think that's going to work. So now we can do maps over tuples, which is pretty neat. And if we run our code, wow, I think we've got the solution in hand, which is pretty cool. Let's try another solution, which is going to be the list of 1 to 0 to 9. Let's take a look at solution 2. Pretty good to me. Looks like we've got the right solution. And not sure there's too much more to show off in this example. One thing here is that our front end back end is a bit redundant. So we can do this, I believe. Yes, split at 3. And we pass in our numbers, which will basically do the take and drop in one operation. And we're still correct. So looking pretty nice here. So I think we can call this a day and probably say that it's working correctly. Let's run our unit test that we had before and see if it agrees with us. I don't know a better way of doing string interpolation like F strings from Python. Maybe there's a cooler way in Haskell. Cool. Looks like all of our tests are passing. We can take a quick look at what those tests are doing. Pretty much exactly what you would expect them to do. Taking some arbitrary lists of numbers and making sure it looks the way that we want it to. So at this point, we're ready to go with our copy and paste into Codewars. Codewars, yes. There. Luckily, Codewars Haskell comes with the control lens package, so you don't have to worry about that. I've noticed not all of the packages you would want to be available is. For instance, I believe data.set is not available. But we're good to go with control.lens. So we passed the initial test. We can run attempt to see if we pass all of the tests, and looks like we're good to go. So we passed, and we can submit, and we can start to look at other people's nice solutions. This uses printf, which is a very simple one-liner solution, which breaks apart the create phone number into a list of 10 components and applies printf. Okay, nothing that fancy. This solution is pretty much the same as ours, except we could have applied split at twice, once on numbers and once on the back end. Should have noticed that, but okay, our solution's good enough. And that's it for today. Thanks for tuning in. So you can see how to go through a Codewars problem for Haskell using VS Code for a nice tight feedback loop, and maybe find some cool Haskell tricks along the way. Okay, thank you very much.